What if you could teach your computer to do all your most boring, repetitive work for you? And hey, that's not science fiction. It is the absolute magic of shell scripting. Today, we're going to build a toolkit that turns your command line into a straight-up automation superpower. So let's get into it.
I mean, think about it, right? Renaming hundreds of files one by one, digging through log files for just one tiny error, or backing up your work every single night. These are the jobs a computer was literally born to do. So in the next few minutes, we're going to assemble the exact toolkit that makes your computer work for you and not the other way around.
First up in our toolkit, we have got to give our scripts a brain. A way to think, to look at a situation and make a choice. This is where our decision-making tools come into play.
Okay, so these are the fundamental building blocks for any smart script. Instead of just running a dumb list of commands from top to bottom, control structures let our script pause, analyze a situation, and decide what to do next. It really is the difference between a simple checklist and a dynamic, intelligent flowchart. So let's break this down a bit. A simple if statement is your basic yes or no check. Think of it asking, hey, does this file even exist? If the answer is yes, we do something. If it's no, we just move on. But if-else, well, that gives us a plan B. It lets us say, if the backup was successful, print success, else send an alert. See? It handles both outcomes, and that's where the real power is. Well, what happens when you have more than two choices? That's where the case statement is just brilliant. Think of it like a menu at a restaurant. Your script looks at whatever the user chose, it matches it to an option on the list, and then it executes that specific order. And that little star pattern at the end, that's your safety net. It's what catches any wacky choices so your script doesn't just crash and burn. Okay, so our script can think now. The next tool we need is the engine, the part that does all the heavy lifting and just powers through those repetitive tasks for us, automatically. This is it. This is where we officially stop doing things by hand. The core idea of a loop is so simple. Why in the world would you type a command 100 times when you can just type it once and let the computer do the rest? This is the absolute heart of automation. It doesn't matter if you're working with 5 files or 5,000. The key difference here, it really just comes down to predictability. You use a for loop when you have a definite, known list of things to work on, like, say, processing exactly 5 images. But you use a while loop when you don't know when you'll be done, but you know the condition that stops it, like keep processing this data while there's still data left. A for loop is just beautifully straightforward. This bit of code right here is just saying, for each number in the list from 1 to 5, do one simple action, print it out. It's clean, it's predictable, and it marches right from a clear start to a clear finish. Now, the while loop is a bit more involved, but it's every bit as powerful. Notice the 3 key parts here. First, we start a counter I at 1. Then we check the condition. While I is less than or equal to 5, we run the code. And this is absolutely critical. We increase I by 1 at the end of each loop. If you forget that last part, you create an infinite loop. And trust me, nobody wants that. All right, we have a brain and we have an engine. The final part of our toolkit is a set of super specialized instruments. These are the commands that make shell scripting so incredibly powerful for slicing, dicing, and searching through text and data. Now, before we dive into those text-specific tools, let's add one crucial organizational tool to our belt, the function. Think of functions like creating your very own custom commands. You just bundle up a series of steps, you give it a simple name, and then you can call that name anytime you need to do that task. It's the key to writing clean, reusable code instead of a messy, repetitive script. First up, cut. And yeah, it's pretty much a precision knife for your data. Imagine a big data file, like a spreadsheet. Cut lets you slice it up and grab only the columns you actually care about. For example, you could take a huge file of user data and just cut out their email addresses, ignoring everything else. It is perfect for isolating exactly what you need. Next is TR, which stands for translate. This is your go-to tool for simple character-by-character changes. Need to convert a whole file to uppercase? TR can do it. Need to delete every single number from a string? TR is your tool. It's simple, it's fast, and it is incredibly useful. This one's a classic. Uniq does exactly what its name implies. It finds and removes duplicate lines that are right next to each other. But here's the crucial part. You have to remember this. The file must be sorted first for it to work right. Always remember that mantra. Sort, then unique. It is the 1-2 punch for cleaning up any list. And now for one of the most famous tools in the entire command line world, grep. If your data is a haystack, grep is the powerful magnet that finds the needle. You just give it a pattern, like the word error, and a file, and it will instantly show you every single line that contains that pattern. It's a lifesaver. But the real power of grep really comes from its options. For example, you can use -I to find error whether it's capitalized or not. Or, my personal favorite, you can use -V to invert the search, showing you every line that doesn't contain your word. Suddenly, you're not just finding things, you're filtering, you're analyzing, and you're transforming data on the fly.
And there you have it. Just like that. With decision makers, an automation engine, and a whole bunch of precision text processing tools, our command line toolkit is officially assembled.
This slide right here, this is your takeaway. It's your cheat sheet. It neatly summarizes our entire toolkit. You've got if and case for making decisions, for and while for all your repetition, functions to keep your code organized, and a whole suite of powerful tools like cut and grep for handling text. This is your foundation for automation.
So now the power is in your hands. You have the brain, you've got the engine, and you have all the specialized instruments. The only question left is, what will you automate first?